Hello, and welcome back to the Mr. Ivanoski Show. For today's segment, we're going to take a look at simplifying monomials. Now, we've already learned how to multiply and divide monomials, and to simplify monomials, we're required to use our knowledge of both multiplying and dividing monomials. We worked through some sample problems in class, but I wanted to dedicate an episode of the Mr. Ivanoski Show to this material. So let's look at the problem 2x squared y cubed over 3x times 9x squared y squared over y to the fourth. There are multiple ways of simplifying this problem, but for this video, we're going to look at two approaches. For the first approach, we will begin by looking at both fractional terms separately, simplifying each of the terms as much as we can. Then, we will multiply both of our terms together to reach our simplified form. So let's start this off. We have the expression 2x squared y cubed all over 3x. Because 2 and 3 are prime numbers, we can't simplify this anymore without making it a decimal. So we'll draw our fraction bar on the line below and just write 2 over 3. However, we have an x term in the bottom and an x term in the top. Now we can use our knowledge of dividing monomials to boil down these x terms. Because x squared is in the top and x is in the bottom, we know before doing any operation that our x term will remain in the numerator because the higher power is in the numerator. And we'll see this right now. So applying our knowledge of dividing monomials, we know we can subtract the exponents that are attached to the x's. So we subtract 1 from 2 to just get x. And we're going to put that x term exactly where we knew it would end up, in the numerator. Not too bad. Looking at the last term of our expression, y cubed, we see that there is a y in the numerator and no y in the denominator. Therefore, we cannot simplify this y any further, so we just write the y to the third power in the numerator. Now we're ready to move on to the second expression, 9x squared y squared all over y to the fourth. Like the first expression, we cannot simplify the whole number any further, so we will just write out our fraction bar and leave that 9 unchanged in the numerator. Similarly, for the x squared term, because there's no other x besides that one in the numerator, we'll leave that term right where it is, unchanged. However, we have a y term in the numerator and a y term in the denominator. Therefore, we can again apply our knowledge of division of monomials. Because we have y squared in the numerator and y to the fourth in the denominator, we subtract the smaller power from the bigger, which will lead us to y to the 4 minus 2 in the denominator. From there, we just leave that y squared term in the denominator because we want it to remain positive. Now we have our two expressions, 2xy cubed over 3 and 9x squared over y squared. From here, we could just multiply from left to right, then simplify. But for this approach, we're going to instead look at our diagonals and see if we can simplify again using division of monomials. Looking at our y expressions, we can subtract the smaller exponent from the larger and write y to the third minus 2 in the numerator. Again, look at the diagonal. We can simplify the 3 and the 9 terms by dividing 3 into both itself and 9. Because both of our x terms are in their respective numerators, we cannot simplify any further by dividing along the diagonals. With that, we are ready to multiply from left to right for both the numerator and the denominator. So we multiply 2 and 3 to get 6. Then we can use multiplication of monomials for the first time in this problem. Applying the rule, we combine those x terms and add their exponents 2 and 1. And we only have one y term in the problem, so we'll just write that in the simplest form when we write said term on the next line. Add the exponents for our remaining x terms. We can write x to the third power on the line. Finally, we simplify y to the 3 minus 2 on the line, and we have reached our final answer of 6x cubed y. Having finished this problem using approach number 1, we are ready to move on to approach number 2. For approach number 2, we start simplifying along the diagonals from the beginning by using our knowledge of division of monomials. Therefore, we will begin by looking at 2x squared y cubed and y to the fourth. We see that these two expressions only have y's in common. So we will simplify this piece of the problem by combining the y's, which means subtracting the bigger exponent from the larger, in this case 4 minus 3. We move on to the other diagonal, which entails a little more simplifying than the previous diagonal. Looking at 9 and 3, we can break this down by dividing 3 into itself and also dividing 3 into 9. Continuing on, we can simplify the x terms by dividing them, i.e. subtracting 2 from 1, and leaving this new positive x expression in the numerator. For our expression on the left, all we're left with is 2x squared, so we write that on our next line. but because we're dealing with multiplication with fractions, it's a good idea to write 2x squared over 1. For our expression on the right, we're left with 3 x to the 2 minus 1 and y squared, so we write that as 3xy squared in the numerator. For the denominator, we have y to the 4 minus 3, and write this as just y on the next line. Continuing with approach number 2, we look at both fractions for areas to simplify using division and see that the only thing to be done is to divide out our two y terms from the expression on the right. This means that we combine the y's and subtract the larger exponent from the smaller, in other words 2 minus 1. Our last step for approach number 2 is to multiply from left to right. With that, we multiply 2 times 3 to get 6 and put the number in the numerator because that's where it began. Then we combine our x terms. To make our multiplication a little easier, let's write x as x to the first. You don't have to do this, but I think it makes adding the exponents a little more straightforward. Multiplying x squared and x to the 1, we combine the x's and add the exponents to get x to the third and place that in the numerator. The last term we have in the numerator is y to the 2 minus 1, and we simplify that by just writing it as y in the numerator. For the denominator, we only have 1 because the y that we did have in there dropped out when we combined the y's.
This leaves us with the expression 6x cubed y over 1, which we can simplify to 6x cubed y. Comparing our results from the two approaches, we see that we obtained identical answers. This concludes today's episode on simplifying monomials. I hope you found the information on this video informative. Have a great day.
Gotta work.
Slight work, light work,
D-Town to the
slight work.
DMV.
Dip low, what's up?
Finally got your girl.